Okay, so the next topic is minors and cofactors. So this is a very interesting one. So minors and cofactors. So first, see what is this minor mean. So if we have some kind of a matrix where A equals Aij, and let's say this is a square matrix. So this is some kind of a n square matrix. So if we delete some row I and some row j, some column j from this matrix, so we now have a matrix with order of n minus 1 because we already deleted one row and one column. So this new reduced ordered matrix is known as a minor of A. Minor of A. So most probably you won't quite understand what I am saying right now. So let me give you an example so it will be super easy to understand. So let's suppose this double suffix notated matrix of order, let's say 3 by 3. So A11, A12, A13, A21, A22, A21, A22, A23, and A31, A32, and A33. So this is of order 3 cross 3. So order is 3. So in this case we can have any kind of minor. So there will be 1 2 3 4 5 6. So there can be having 9 different types of minors, but in this case I will just uh, consider these upper row and write the corresponding minors. So if so, assume I'm going to delete this uh, first row and first column. So the producing minor, we represent it as M11. So this minor will be having uh, A22, A23, A32, A33. And normally we are representing this minor as a determinant. Okay, so the first minor, so I forgot to say that in the first topic, first part. So we delete a specific row and delete a specific column, then the producing matrix is a minor, so it's a determinant of this new matrix. Sorry. So the first minor will be something like this. So now assume I'm going to delete this row again and this column. So the producing minor, now you can guess. So it will be 1, 2 because first row and second column. So if I delete this row and this row, the remaining one will be 2, 1, 2, 3, 3, 1 and 3, 3. So A21, A23, A31 and A33. So likewise, now we can define any amount of minors. So I will just follow the order. So I'm deleting this column and this row. The producing minor will be M13. So now we have A21, A22, and A31, A32. So likewise, you can delete any row. You can delete any row and any column and produce the corresponding minor. Okay. So remember, you must take the determinant of that newly created uh, row and column reduced matrix. So it is known as a minor. So what is a cofactor? So basic cofactor is very simple thing. So now we know what is minor means. So some minors will be having a sign, which means it could be plus or it could be minus. This could be plus or it could be minus. This could be plus or this could be minus. So how do we determine that specific sign? So that's why we have the term called cofactor. So cofactor means basically nothing. It's just a signed minor. Cofactor means a signed minor. Okay. This will just determine what is the sign of this specific minor. Okay. So we know that we determine a minor by the sign of m. So in this case, we determine the cofactor by the sign of alpha. Okay. So the cofactor of let's say first row and first column we determine by alpha 1 1. So the cofactor of first row and second column alpha 1 2. The cofactor of first row and third column alpha 1 3. So likewise it will there will be 9 total cofactors if the matrix is order 3. The matrix is order 3. So if the matrix is order n, then such a matrix will be having n amount of cofactors. Okay. So now when we are determining this cofactor with minor, we use this specific pattern. So if we need to determine some arbitrary ij cofactor, what we basically do is we get the power of -1 I plus j, then the corresponding minor like this I j. Okay. So if we wanted to take the cofactor of 1 1, what we have to do is -1 1 plus 1, then minor 1 1. So if you want to take cofactor of 1 and 1 2, then -1 1 plus 2, then 1 2. So likewise, now you know the pattern. You can take any amount of cofactors like this. So it is super easy. Okay. So all you have to remember is, let me go to the beginning. So minor is something like this. Okay, you just remove a specific row and a specific column, and the cofactor is something like this. You just determine the sign of that specific minor. Okay, so this is minor and this is cofactor. Okay, so that is the topic about cofactors and minors. So let's do some example, so you will understand this procedure correctly. So let's suppose some kind of a matrix. Let me. Okay, so let's suppose some kind of a matrix A equals 2 3 5 1 0 1 2 1 0. So let's say you ask to find the determinant of this specific matrix. Determinant of this specific matrix. Uh, so in this case, there are some specific terms that you have know. So for this in this case, I don't think it is better to explain right now. So I just in the next clip I will explain how to find the determinant. So for now, let's find some minors and cofactors. So in the next clip, I will explain how to find the determinant by using this minor and cofactors. Okay, it is super easy, but for get a better understanding, first let's do some basic example. Okay, so suppose I wanted to find the minor 1 3. It's just the arbitrary minor. Okay, I don't know the order. So 1 3 means basically now I must remove first row and third column, so the producing one will be uh, 1 0 and 2 1. So you know how to find the determinant. So 1 1 minus 2 0, so the outcome will be 1. So let's say another arbitrary minor, let's say m2 2. So basically you have to remove second row and second column, so the remaining one will be 2 5 2 0. So 2 5 2 0. So you know how to take the determinant minus 2 5. So remember, the producing one will be a minus value, but we take the determinant, so the answer will be 10. So likewise you can find any other remaining minus as well. So let's find the cofactor of this m13. So we know minus 1 1 plus 3 determinant 1 3. So 1 plus 3 basically 4. So the power of minus 1 to 4 will be just simply 1. So we know the answer of this one, so it will be 1. So the cofactor of 1 3 will be 1. And let's look at this one as well. So minus 1 2 plus 2 m2 2. So this will be again 1, and this will be 10. So the cofactor will be 10. So this is how we are going to find minors and cofactors. It's pretty much easy. Okay, so that's it for now. I'll see you in the next clip.